Good morning, everybody. Today, we are moving further to differentiation from the first principle. Differentiation from the first principle. So, but before that, I would like to break it down for us. This aspect of differentiation, let me say differentiation. There are two parts in calculus. Calculus is divided into two parts. We have the differential calculus and we have the integral calculus. But today I am talking on differentiation, that is differential what? Calculus. Under the differential calculus, what are we trying to do? We are actually trying to find the slope of a curve. Slope of a curve. Now let me bring you back to where you guys are in your, let me say JSS3, SS1. You actually talk about equations on a straight line. Equations on a straight line. You will notice that in your equation of a straight line, to find your slope, it is very easy. Your slope is given to you as y2 minus y1 all over s2 minus x1. Why is it like that? Why is it like that? Look at it here. Let's assume I have two coordinates here. And I have 2 points here. Then this is a line. Now, to find the slope of this line, let me call this one x1. This one x2. This one what? y1. This is the y coordinate. And this one is what? y2. So to find my slope is the angle at which this line is lying on this horizontal line. The angle between them. So this one has formed a triangle indirectly. That means for me to find this angle, I need to find the value of this side and the value of this place. And for me to get the value of this place, all I have to do is what? x2 minus x1. Because from here to this place is my x2. From here to this place is my x1. Now for me to get this one, the same thing is happening. From here to this place is my y1. From here to this place is my y2. From here to this place is my y1. From here to this place is my y2. So therefore I can write this one as also what? y2 minus y1. So if you look at the triangle, this is the triangle here. This is the angle. And this side is my what? y2 minus y1. This side is x2 minus x1. So what do I need to do? To find the slope is the angle at which this line is lying to the horizontal. So therefore, this is my opposite. Wherever the angle is facing is called the opposite. This side is called my adjacent. So therefore, tan theta equals to opposite is what? y2 minus y1 all over what? x2 minus x1. Now, the reason why we remove this tan theta is because this is it is under coordinate geometry. So under coordinate geometry, what we talk about there is what? Coordinate of points. We only talk about points. Points, we can use point to find the distance between, we can find the distance between 2 points rather. We can find the slope. We can also find the midpoint. Everything we do under this coordinate geometry has to do with what? With points, not with angle. So therefore, that is the reason why this tan theta is not appearing in the formula of the slope. So therefore, I can now say tan theta is given to me as what? M. So therefore, slope M equals to y2 minus y1 over x2 minus x1. Now you can see that I can find the slope of this line. So on this line, if I decided to choose another point, another 2 points there, I still find that same slope, I will still have the same answer as what? As these 2 points. Therefore, what I'm trying to tell you here is that at any point on this line, their slope is equal. So anytime I'm having a line and I'm asked to find the slope, I can pick the point at any what? At any part of this what? On this line, I will still have the same answer. So this is the slope. The slope is the change. The change in y and change in x. That is the difference in y and the difference in what? In x. But the reverse is the case for what? For a curve. In a curve, like let me say a quadratic function given to me in this part, a quadratic what? Function. The slope of a curve, this is a curve, is different from the slope of a line. For me to get the slope of a line, I can get it at any point. But the slope of a curve at every point are different. The slope of a curve rather, at every point they are different. So a way of finding, when you are doing your quadratic equation, to find this slope, all I need to do is to pick a point here, then draw a tangent to it. So this tangent, I can now what? Find my slope between one of the what? One of the points there, I will get my answer. But the best way to find the slope of what? Of a curve is what? Is using differential calculus. Using differential what? Calculus to find the what? The slope of a curve. So at any point, in your question, it will be like this. It will be given to you like this, in this way. In this way. Y equals to x squared. It can be a function, a quadratic function can be 2x squared plus 4x plus 5. This is a quadratic function. This is a quadratic function. So I can either find the slope, but today I am going to talk about the general rule. There is another rule that I can use to find this what? The slope of this. The general rule, and all I need to do is just bring this 2 down here, minus 1 from this one. I will explain that in the next video. But I'm talking about first principle. Now, if you look at the first principle, it is very, very long. So, but what they are trying to do under this first principle, or differentiation rather, is to find the slope of a curve. So there are different ways of finding the slope of a curve. One of the ways is what under differentiation is what? The first principle. So we have different methods of finding slope of a curve under differential calculus. One of it is what? Depending on how the functions appear. If the function is a straight function like a curve function, I can either apply the general rule there. But if it's like this, I can also apply the general rule. But now I'm going to explain the first one, the first principle. Now under the first principle, you have to find the first principle. Don't forget that I am asked to find the slope. And for me to find my slope, it is the change in y and change in s. Just like what? Y2 minus y1. Y2 minus y1 is the same thing as what? The difference in what? In y. x2 minus x1 is the same thing as what? The difference in what? In x. So therefore, let me add the difference to this y and difference to this x. So therefore, I'm going to have y plus, now the difference in y, I can call it dy. The difference in s, I can call it what? Dx. Then raised to power of what? 2. So in everything, I must find a way to bring this ds under this dy, because my slope says that m equals to y2 minus y1 over x2 minus x1. So this change in y is same thing as y2 minus y1. This change is x, same thing as what? X2 minus x1. So and the formula has to be like this. So therefore, I have to bring this dy and this dx as a what? As a rational what? Value. So what do I need to do? Since I have what? Added the change in what? Y and the change in x. So how do I bring this dx down to this place? I have to open this bracket first. So therefore, y plus dy equals to x plus dx all over what? X plus, another bracket. Since it is 2, I have to what? I have what? 2 of it here. So dy, y plus dy equals to x times x will give me x squared. X times dx will give me x dx. Dx times x will give me s dx. Dx times dx will give me dx squared. So these and these are the same thing. So I'll add them together. I'm having x squared plus 2x dx plus dx squared. So when I add this together, I'm going to have this. So now the next thing is I will bring this y. I have to eliminate this y away from this place. I have to bring this dx down to this place. So take this y to the other side. I'm going to have dy equals to x squared plus 2x dx plus dx squared minus y. Don't forget that your y from the equation is equal to what? x square. So whenever I see y, I'm going to put what? X square. So the y equals to x square plus 2x dx plus what? The x square minus what? X square. So this x square, we cancel this x square. I'm left with dy equals to 2x dx plus the x square. So the next thing is now find a way to bring the x here. All I need to do is divide the both side everything by the x dx. So this we cancel this. This we cancel one out of this, give me what? 1. So I'm left with dy over dx equals to 2x plus dx squared. Now I have to limit the x tends to 0 because the slope I'm looking for, I must eliminate what? Ds. So how do I eliminate ds? By what? Limit it to 0. So therefore, I can have what? Dy over ds equals to, don't forget, limit ds to 0. So wherever I see ds, I'm going to put what? 0. So my dy over dx becomes what? 2x. So that is my answer. So my next